Welcome to the video lecture on DC generators. This is the final subsection under DC machines. So I will brief you through some DC generator types and we will discuss what are their characteristics. So DC generators are going to convert the mechanical energy into electrical energy. So it is going to produce a DC voltage at the output of the machine. Similar to the DC motors, you can have 5 types of DC generators. They are basically different from the way that the field winding is connected. So the first type is separately excited DC generator. Then you have the shunt DC generator, series generator, compounded DC generator, and finally you have the permanent magnet DC generator. So when you compare the DC generator and DC motor, field winding would be same how you connect, but the only change is that when you consider the armature winding or the armature circuit, current flowing direction would be opposite. Now the internally generated voltage is going to be higher and the output voltage would be lower. So that's the only difference when you compare with the DC motor and DC generators. So first we will look at the simple DC generator, simplest one, which is the separately excited DC generator. So you have a separate field winding and separate armature winding. So this is the field winding, RF is the field winding resistance, LF is the inductance which represents the flux generation, and then you have the R adjust which you can use to control the field current. Thereby you can control the amount of flux produced inside the machine. Then here you have the armature circuit, internally generated voltage, armature winding resistance, and then this is the terminal voltage. Now you could see that the armature current is now flowing out of the circuit. Now the field current can be expressed as Vf over Rf plus R adjust. Then you have the internally generated voltage, EA is equals to K phi omega. So phi can be controlled by controlling IF. So once you have the internally generated voltage, the terminal voltage is Vt equals EA minus IA RA. So you could see EA is now larger than the terminal voltage Vt. So the induced torque of the machine is equals to K phi Ia. In the shunt DC generator, the field winding is connected to the output voltage. So this is the armature winding and this is the field winding. So now you get the armature current that would be split into two components, one for the field winding operation and the other one is to the load. So the field current IF is equals to Vt over Rf plus R adjust. Terminal voltage Vt is EA minus IA RA. Now IA, the load current, would be IA minus IF. In the series generator, field winding is connected in series with the armature winding. So the terminal voltage Vt is equals to EA minus IA times RA plus RF. So here RS means the RF value. So another thing is the armature current, field current and load current are going to be same in the series DC generator. So those are the three types that I only discussed three types. The other type is the compounded DC generator and permanent magnet DC generators, which I will ask you to go through the literature and find out what are their characteristics. So the references that I have used for this section and for the whole DC machines section that I covered, these two references. So with that, I will conclude the lectures on DC machines. Thank you.